Welcome, everybody. Welcome, everybody. I'm Greg Ostrovich. Welcome to the combined Denver and Boulder Java User Group meeting. We're always looking for DJUG speakers, so that's a reminder. Let us know if there's content that you want to see, and we'll try to schedule a speaker. Because we've been doing these virtually, we have a lot more options available because we don't have to fly a speaker in. Email myself or Matt Rabel or hit us up through the Meetup site if you're interested in a particular speaker, or even if you want to speak. I'm going to do my housekeeping announcements. If you need to use the restroom, hopefully you're in your own place and you can find it. Tech Systems is our food sponsor usually, and we appreciate their support. Tonight's dinner is sponsored by whatever's in your pantry and whatever's in your fridge. Andrew Rawson from Tech Systems, arawson@techsystems.com, or Courtney at techsystems.com. You can reach either of those if you're looking for staffing. JFrog is another sponsor, and they have their monthly August sweepstakes. Everyone has a chance to be a winner. All of those that enter the raffle to win a Nintendo Switch and 2 games will also win an Iron Frog t-shirt. The winner will be selected after the end of August. You can scan the QR code, it should be in the chat, or use the bit.ly link in the chat box as well. Apex Systems is another sponsor. They're usually our beer sponsor. Tonight's beers are sponsored by whatever's in your fridge again. But we really appreciate Apex Systems. It's Brad and Collip. Reach out to them if you're looking to hire and you're looking at another staffing agency to reach out to. Develop Intelligence does a Pluralsight drawing, and that's for training, online training. Ace Van Wan Seal is our contact there. And Develop Intelligence is always looking to hire technical instructors who specialize in several technologies for contract opportunities. Those include Java, Golang, JavaScript, React, DevOps tools like Kubernetes and Docker, and many others. Reach out to Jarrett, J-E-R-E-T, at developintelligence.com if you want to follow up about that. Amazon is another sponsor. Chris Almond or Sam Ayer there. They have all sorts of opportunities in all sorts of different stacks. So reach out to them if you're looking. Okta is, we so appreciate them. They're one of our sponsors that actually does this online meeting. Matt Rabel runs that. We usually do food as well, but lately we've been meeting virtually. NextGen is another sponsor. And some of these sponsors we're doing drawings online, door prizes, if you will, at the end of the meeting. And Mike Zuedo will handle that. And you'll see information in the chat about how to do that. So Beth.Crowley, C-R-O-W-L-E-Y at nextgeninc.com. They don't have any openings right now in Java, but reach out to them. They constantly update, and they're doing a gift card tonight for the drawing. AgileLearner.com, which is a Venkat's company, and we usually do a drawing to a subscription to AgileLearner.com, and they'll be putting on an amazing conference coming up. They're just trying to, they've rescheduled because of the COVID stuff. JetBrains is another sponsor. We give away a couple of IDEs from them. Usually it was IntelliJ, but it's kind of that broad, that more broad IDE that covers a lot of stuff. A quick thank you to the DJUG board, Matt Rabel, who is running the meeting, and we really appreciate that. He also does the speakers, and when we used to meet in person, locations. Mike Zuedo handles the door prizes, and we really appreciate that and want to thank him. And Zeddy Chinfang does a lot of the operational stuff, including social media, and announcements, and other things for the JUG, and we just really appreciate everybody for the help they give. And now I'd like to bring up Chris Wojna from the Boulder Java Users Group, because they have some sponsors to thank as well.
Hi, thanks very much. Just want to give some quick shout outs and thank yous to our sponsors. Likewise, Tech Systems, America's foremost technical recruiter, and our representative, very capable Anastasia Alexenko. Very easy, very knowledgeable person to talk to if you have any questions about your career or what the environment is like, whether you're actually looking for a job or looking to hire someone or just want to know what's going on. We'll be happy to get you in touch with her, or you can find her on our website. Rule 4 Cyber Security and Emerging Technologies. They were Colorado's Technology Association winner this past year. really a tremendous forward security company. No fluff, just stuff. The Ubercomps. Jay Zimmerman has been a longtime supporter of the front range Java user groups. And of course, again, Venkat Subramaniam, Agile developer. We have a token that you can use to access his learning videos. If anyone is interested in that, the first person that contacts me through Meetup can have that. We also have an IntelliJ JetBrains license. Same thing, first person to contact me, you can get that. O'Reilly Books, and also JFrog. Back to you. Thanks, Greg.
Thank you, Chris. All right, for tonight's presentation, Chandra Guntur will be talking about Beyond Entitlements for the Cloud Native, and this is a little bit about that talk. A policy engine is a tool that allows for checking user privileges as well as evaluating a responsibility matrix based on dynamic data for a given user. A policy engine is not only an entitlement management system, but also provides for functional evaluation of conditions that result in deterministic responsibilities for a given user or actor. This session shows how to utilize Open Policy Agent with Spring Boot and HOCON to produce a responsibility management solution that scales to volume and performance needs. Some hiccups that were faced while deriving the most optimal solution are also highlighted. A short explanation of some tooling built for validating the policy files in the IDE will also be discussed. And a little bit about tonight's speaker. Chandra is a technologist in the financial services industry since 2003 and is programming with Java. He's been doing that since 1998. Chandra was selected as a 2019 Java champion. He is a Java user group leader and helps run one of the largest Java user groups, the New York JavaSIG, and leads the New York JavaSIG Hands-On-Workshop, or HOW, conducting code workshops and creating Code Katas on core Java features. He's a frequent speaker at Java user groups and technology conferences, including Oracle CodeOne, Oracle Code New York, QCon New York, Devnexus, and GIDS India. Chandra holds a bachelor's degree in technology, electrical and electronics engineering from Sri Venkateswara University. You can find Chandra on Twitter at CJUNTUR. And without further ado, let's bring up our speaker. Thank you, Chandra. Chandra Guntur.
Hello, everybody. Hello, everyone. Thank you to NYJavaSIG and NYJavaSIG for hosting me tonight. I look forward to an interactive session today. Obviously, we can't be interactive in the real sense of the word verbally, but definitely please do post your questions on the YouTube channel. I'll be happy to answer them. The format of the session will basically be me going through a set of slides, and I will probably break it about the halfway mark, look for any questions, and see how we can tackle those. And we will move forward from there and complete the rest of the session and leave some more room for additional questions right after. So if that works, let's get started. I'm going to share my screen real quick. Okay, I am ready to share my screen. So, okay, I'm assuming my screen is now visible. Unfortunately, with my full screen, I'm not able to look at what you can. So, very good. Okay, great. So let's proceed. So today's topic is Beyond Entitlements for the Cloud Native. It is about scalable responsibility management. And the tooling that I'm going to talk about is Spring Boot and Open Policy Agent. So without further ado, a little disclosure from my workplace. About me, I'm a technologist. I don't want to spend too much time because thanks to Greg, I've already been introduced. I currently work at BNY Mellon in the Java Platform Engineering Group. I am one of the representatives for the Java Community Process Executive Committee for BNY Mellon. I'm a Java champion and a JUG leader, and I speak at a few conferences. In addition to that, I live in New Jersey with my wife and twin daughters, and I've been living here for about 23 years in the same house. I definitely am looking for a change in house, but that's a different story. We'll talk about that later. Great. So let's get started. What is the agenda for today? We're going to talk about responsibility management. We'll talk about some technology choices that we used to come up with our responsibility management solution. We will cover some amount of architecture on how we approached and solved this problem. I will include some code samples. Unfortunately, These code samples are in a PowerPoint or a Keynote format, and they're not something that I'm going to use in IDE, at least tonight. Maybe in another future session, we could do more hands-on. And we'll also talk about a plugin that we helped build out, which eased our development life cycles. So that is our agenda. That's what the ballpark is. And probably after the technology choices, I'm going to leave some room for us to have a round of question and answers. So what is responsibility management? Before we get into any kind of solutions or architectures, we first need to define a problem statement. And let's start by looking at a few scenarios on how there are situations where you actually come up and need a responsibility management. Great. So let's take a quick look at some scenarios. The first scenario, there is an enterprise lightweight directory access protocol, and a service needs to know if a user is a member of a certain enterprise LDAP group. Now, they may actually have situations where access is either granted or denied based upon membership in a group, or access is granted or denied based upon a lack of membership. Now, what if there is another service that also requires the same kind of access? What if there are multiple services that require the same kinds of access? What if there are users who are moving in and out of the organization or in and out of the company, who move, leave, or join, right? How do you handle these? So typically, you would have some sort of an application that creates a service for the LDAP, and everybody uses that, which is great. So let's look at why this is important. Let's look at scenario 2. Now, instead of an LDAP group, what if I have an email group or an Active Directory AD group? And similar to what we had with LDAP group, you have access being granted or denied based upon membership or lack thereof. What if multiple services needed that? Once again, what if people were moving in or out of the organization or the company itself? How do you handle that? Now, the other scenarios which can get a bit more complex is what if you have conditions such as, a user is a member of a certain LDAP group, but is not a member of another LDAP group, but is a member of another email group, and is allowed to make some kind of a monetary amount of orders when they are procuring or doing whatever, and has some HR responsibilities, such as 2 direct reports in case of the example I took. Now, this is a bit more complex. So not only am I looking at one single service or entity, such as LDAP, now I'm actually expanding to beyond one, and I'm actually looking at multiple services to find the information to validate whether or not this particular employee or user has access and should be allowed or denied this particular request that they're trying to make. We haven't even got into what this request is about, right? So there is a more complex situation that we've created where, based upon conditional checks, we are determining whether or not this employee or this user has access, should be granted or denied whatever request they've been trying to attempt. Now, what if there are multiple requests for different groups and different amounts? How do you handle that? Do you write some conditional logic and write code every time when you need to access this? Where do you store that? What if there are services that have similar functional constraints, but with different values, right? Instead of LDAP 1, maybe they need to look at LDAP 7. Instead of maybe a dollar amount of 200,000, maybe they need to look at a dollar amount of 75,000. How do you handle this? And once again, how do you handle any kind of policy maintenance, right? You wrote some things, you wrote some conditions in your code. How do you maintain it? What if the numbers change tomorrow? What if the LDAP groups change tomorrow? How do you follow any kind of configuration management guidelines in that? Where is your Sdlc process for these policies? Where is your guarantee that you can reproduce what was available, say, 6 months from yesterday, right? How do you manage those? And overall, the same boiling question, what if there are people who are moving in and out of the organization or in and out of the company? How do you handle this? Finally, the last scenario that I would like to place is, what if you had a more detailed, finer grained, I would not say completely fine grained, but a finer grained problem statement where you are looking at a user to belong to a certain domain, a business unit, a line of business, or whatever you call it. A user belongs to a certain domain and has a certain cost code identifier, such as a department code, a management code, a business unit code, whatever you call it. And then is looking for access in a given environment, say production or QA or development. These could have different values. Maybe you're allowed to access QA and development, but not production. How do you make that distinction? And their specific action comes into play, whether they want to edit something, delete something, create something, etc. The action that they take. And then, of course, What are they acting upon? Is this a database? Is this some sort of an application front end? Are they trying to delete a user from an admin console, etc.? There are different kinds of resources. So given the constraints of a domain, a cost code identifier, an environment, an action, and a resource, how do you scale and determine if a user is allowed to perform a certain action? Right? These are the 4 scenarios that I want to sort of highlight as problem statements that can be potentially solved by us creating what is called a responsibility management system. Now, these are not the end all. These are some of the fringe scenarios. There are extremely complex scenarios that you could create. Examples could include you not only just depend on data, but on functions, what time of the day it is. Or if, let us say, 2 other users who have already approved, am I allowed to actually approve some requests based upon separation of duties, separation of concerns? There is logic alongside data that is to be taken into consideration when giving control. Now, when your normal circumstances, you could also, just highlight and say, hey, you can do X back, X standing for any of the alphabets that support based access controls, such as R back, A back, OR back, R back, etc. You have different kinds of systems, but all of these simply use data and contexts. They do not actually have any kind of logic built into them. So I'm going to show you some examples how typical solutions have been provided in the past for solving problems where logic is required in addition to data. So let's take a quick look. Now, before we go there, for the scenario 4, once again, the same problem statements exist. What if there are different values for different requests? How do you handle that? You have to create something that can accept parameterized values. What if there are different services with different functional constraints as compared to what my current use case has? What if the other environment does not care about what resource you're operating on, but only cares about organization, environment, and action, right? You may have bespoke conditions based upon individual requests and individual requirements. Once again, who manages role responsibility per domain and user role mappings? And we will cover a lot of this as we go along. Role responsibilities versus user roles are important mappings that we will talk about. A role responsibility mapping is where you define a certain role and assign it some permissions or responsibilities, where you say, as a developer, this person is allowed to commit code. As a developer, this person is allowed to check out code. As a developer, this person is allowed to actually query a dev database. Once again, you could have another use case such as a buildmeister, the person is allowed to actually build using some continuous integration build tool, create a release, and deploy it into a set environment. Now, a developer may not have this role. This is a role responsibility mapping. Likewise, a user role mapping is where you assign users to individual roles, where a role and responsibility define what is available. A user role mapping provides with who is allowed to use what is available. So a combination of user role mappings and role responsibility mappings lead you into a situation where you can make deterministic evaluations on a coarse-grained basis, right? And this is quite important. Once you've had some amount of coarse-grained entitlements that can be shared across the organization, used in multiple locations, you create what is called profiles of users. And this is very important, especially in a financial institution or any large institution that has any audit associated with it. Once again, the same standard question arises: who manages movers, levers, and joiners, both within the company and organization? How do you handle those situations? So let's dig into this. So common solutions to these problems, right? It's not that we're trying to solve a unique problem. This problem has probably been solved everywhere using different mechanisms. So let's take a look at what common solutions are. And before going into common solutions, let's just think about this. There is a data portion to this, and then there is a logic portion to this. So let's first take a look at the data portion of this. So common solutions for data is to create direct connections to any kind of integrated services, such as LDAP or Active Directory. So each application or service that actually needs some amount of information directly queries the LDAP or Active Directory. Guess what? There is a problem. What if there are 50 to 60 applications that are directly hitting your Active Directory at the same time? You will definitely start noticing some latency. It may also put back pressure on your Active Directory or LDAP. Is this something you are ready to handle? that is something to be considered. Now, in addition to that, you also have something like a user, approver, or manager information that needs to be queried. And this can be queried from some systems that are proprietary. There are corporate data services that you can handle, and you can probably get this information out of it. This is placed in bespoke corporate directory services. You may or may not have access to such. Now, in addition to that, you have what is called role responsibilities. And these role responsibilities may be stored in some kind of a local persistence domain. So you basically have your own local database, and you have stored, let us say, given roles and responsibilities in such a domain for your database. Now, there may be some other application which has another set of role responsibilities, and they maintain it locally as well. This leads to an audit nightmare, because once you look at audit, you have no way to create a profile of an individual across your organization. You can only create one across your own specific application or service, right? So that is another common solution. User role mappings are another, we already covered role responsibilities. User role responsibilities are basically where you map a user to a given role. And these are usually stored in a local persistence or in proprietary systems. So local persistence, you store in a database all the users that have a certain role. You could also store them in some kind of external proprietary system. Now, once again, your mover, leaver, joiner problem arises because once you store them locally, you have to maintain whoever joined or left the organization or company. These are the common solutions that existed for data, right? And let's take a look at how functions or logic have been attempted to be solved in the past. Most complex functions are usually or typically coded into the application or service. So this was what was normal in the days of the yore, where people would simply write lengthy programs that had conditional logic built into them, saying, hey, if you are in a certain role or if you're a certain individual, this is what you could do. And then they started sort of graduating and evolving towards a newer model where you would create an independent service or microservice, which would hold all this data, and everybody would simply query that, right? In addition, there are applications that use embedded rules engines, such as rules or bespoke JSR 94 implementations, which would simply, they would query given the data, given their requirement, and get some logic from the rules or any kind of rules engine to give them a result back. Last but not the least, there are some applications and services that use proprietary entitlement systems for evaluation, such as they would create an entitlement application itself, which would be central either to the organization or company, and they would go through that system. Now, the problem with entitlement systems, again, is the fact that it is mostly data-driven and not functional. So a functional part of an entitlement system would most likely be a context-based system where you would add additional context that is read from your application, and based upon that context would provide you some output. So there are some issues with each of these, and which led to us having to solve a problem that we found where we were. Now, obviously, your situations will be different, but highlighting these may actually provide you some amount of information that you may have already missed, or you may choose to discount because you don't need that. The choice is yours, but I'm just sharing what we found going through our, use cases. Great. So enter Responsibility Management Service. The Responsibility Management Service is a solution that can help you manage dynamic privileges and entitlements. Dynamism is brought about by logic, and it is brought about by you supplying a certain amount of static data along with your request, and in return getting back something that is evaluated on the fly. This could include either time-based constraints, it could include other external criteria that is not available to your entitlement systems, such as separation of duties, separation of concerns, existing approval chains, and workflows. So there are different dynamics that bring about different values in terms of output and responses to what is allowed to be, function or not. So let's take a quick stab at what a responsibility management cycle looks like. What is responsibility management? Obviously, I cannot put this all in a single slide and tell you this is responsibility management. However, I have dared to make an attempt, and it is in the appendix. So if time permits, we will actually take a more complex look at how responsibility management can be handled. But on a short note, let's take a quick look at what the cycle looks like. The first thing you'll notice is there is policy administration. You go ahead and create policies, and we'll talk about what policies mean. Essentially, policies are logic that take in data as input and use that logic to provide you a yay or a nay, an allowed or a denied, or something similar to that. So that is policy administration, where you create new policies and you get them to be stored somewhere. Once you create and store the policies, you move on to distributing those policies, where they are made available to some kind of engine that can evaluate such policies. So this is a distribution mechanism. Once again, distribution mechanisms are very important and separate from the storage, because you can add additional entitlements on who can and cannot receive such and such policy. Some policies may have guarding around them. So you may want to not share your policies with everybody, but with a certain limited audience or set of applications. And that is where dissemination comes in as an essential part of the cycle for policies. Once you have policies that were created and distributed to systems that are allowed to use it or users that are allowed to use it, you have an evaluation mechanism. An evaluation mechanism is where your policy is actually executed and a result is acted upon. There is no point in just creating a policy and evaluating it. Its result needs to be acted upon, which is where a policy enforcement comes in. So you start using the decisions that the policy provided for you. So instead of just relying on you creating the policies locally, you are deferring the policy evaluation to external to your system and using its data meaningfully within the scope of your application boundary. That is policy enforcement. Great. And now comes the final portion of this equation, where you have potentially got some policy, and obviously with time, a policy may undergo some changes, and also the users may actually undergo some changes. So there is static data changes, there are reference data changes, and there is policy logic change as well. And all this fits into what is called a policy reconciliation bucket. A reconciliation could be based upon data, it could be based upon users, it could be based upon the role responsibility mappings, or it could be based upon the logic. Multiple things are included in a policy reconciliation, which leads to you maybe potentially creating a new policy, and the cycle repeats itself. So this is the life cycle of a responsibility management, and a policy life cycle is what it is termed as when you put it into operation. So I'm going to see if there are any questions. Matt, please do let me know. But just wanted to make sure that there is understanding of that there are these 5 different parts of the cycle. A quick look at how the...
No questions. Everyone's just happy to be here.
Awesome, awesome. So here is the appendix where I have a much more detailed picture, and we can go back to this once we've finished through the slides. Great. So how do we design a right solution? The right solution is to create a responsibility management system. And this responsibility management system is the one that federates all the calls to integrated services such as LDAP, Active Directory, and any of the services that you refer to. Now, the benefit of doing this is that you reduce the back pressure on your LDAP and Active Directory. You can cache some values on a temporary cache basis, time-based, etc. You can quickly respond to multiple queries which use the same information. You could also build out more logic. So let's take a deeper look at that when we go through this. In addition, a responsibility management system can provide roles and responsibility mappings on a per domain basis. So there is a centralized mechanism of providing roles and responsibilities. So this could definitely help when you are looking at a specific user within an organization. You can quickly determine what their roles and responsibilities are. How do you do this? By providing a user to role mapping on a per organization and per domain, which is also a responsibility of the responsibility management system, at the risk of repeating myself. Now, in addition to all this, we actually covered a topic when we were talking about scenario 3, is that there is a certain amount of Sdlc and audit requirement for anything that you do, especially in a large organization. You made a change, that change makes an impact. Now, someone was allowed to do something or denied to do something will potentially lead to an audit trail request down the line. How do you do that? A responsibility management system has to, as a solution, provide you with certain amount of Sdlc and audit. Someone changed a policy, you should be able to determine when it was changed, who changed it. So some sort of temporal milestoning of the data along with who made the change and when is important and should be provided by responsibility management. In addition, a responsibility management system should provide for you a built-in policy engine that can evaluate complex calculations and functions. Now, there are three typical parameters that are useful when you use a policy engine. There is data that is provided as inputs. So if a user is asking to delete some data, is an input provided by the service consumer. Hey, user X is trying to delete data Y. Is provided on database Z. Is provided as an input by the service consumer. And then there is data queried from the integrated services such as LDAP, some entitlement system, or Active Directory, etc., to determine if this user is allowed to do this. And then there are policies, which is functional logic that is provided on a per domain basis. Is this user allowed to do this action? Is this a user allowed to perform this action on this particular domain is something that is evaluated using the policy. So a combination of the data provided as input, a reference data that is provided from the integrated services, and the policy, which is the functional logic on a per domain basis, can determine a yay or a nay for a given request. The responsibility management system also should be able to cater to your mover, leaver, joiner logic, which is when a user joins, moves from the organization, or leaves the organization, or likewise joins or leaves the company. Last but the most important fact is, if you are building on the cloud native, if you're building something for the cloud, you definitely have a lot of services that run on containers, which would require access to such a system. Such a system, therefore, should be horizontally scalable and highly available for varying request volumes. You have to somehow scale to a level where you can never be down, because a lot of systems now depend upon such an external system to provide evaluation logic for them. So these were the constraints at which we started looking at how to build a responsibility management system. For short, we call it RMS. So in future slides, if I refer to RMS, it stands for Responsibility Management System. Great. So let's take a quick look at how systems looked like before we moved into creating RMS. I'm going to have 4 typical application scenarios listed here. Once again, there could be multiple scenarios. I'm just limiting myself to 4. So let's start by looking at the pink one up top. So the pink one up top shows your database and an application. And for quick legend, we have RRM, which stands for Role Responsibility Management, and URM, that stands for User Role Mapping. So a role responsibility mapping is basically where you define a role and give it a set of responsibilities that are allowed for that given role. A user role mapping maps an individual user to one of the roles defined in the role responsibility mapping. So through this, I can determine what responsibilities a user is allowed, right? Great. So with that legend, let's go back into the pink application scope and notice that there is a database. And in this database, I have a bespoke role responsibility management stored within the database. So I am customizing my own role responsibilities in my database for this application. I have application logic, and my application logic uses 2 different integrated services, an LDAP client, the local lightweight directory access protocol client, and it connects to LDAP. And it also uses some bespoke user service client. And we'll not talk about what this is. It is just a proprietary system that provides for some amount of user information. I just made this up for, as an example here. In addition to do this, there is user role mapping that is provided by some external entitlement system outside of the application. What am I doing here? Outside of my application, I have defined a user and mapped them to some string that represents a role, which the role is actually defined in my local database. So I first query the external entitlement system for a given user, find out their role, come to my local database, determine their responsibilities, and use it in my application logic. This is scenario number 1. The second scenario, the blue, is basically where I have user role mappings defined locally, whereas I define that a user is mapped to a certain role in my database, and I have application logic. This goes into an Active Directory client to get some email groups or similar, and it also goes to this bespoke user service client, which can give me some more details about the user, such as who their HR manager is, who their reporting structure is, what their management unit is, etc. Right? In addition, I have what is called a role system, RRM, and this role system is where I am defining centrally what roles and responsibilities map to for the entire organization. Now, this is a complete reversal from the above application. In the above application, I had user roles defined externally and role responsibilities defined locally. In this case, I have user roles defined locally. I have role responsibilities defined externally. This is another use case. It's possible. Now, in addition to add to that complexity, I also have a custom service that I'm fetching information from. This could be something that simply evaluates time of day and makes that determination for me whether to say yay or nay. If it's a weekend, do not allow them access. If it's a weekday, allow them access. Maybe that is as simple as what the custom service is providing for me, right? It could be more complex, but I'm just building up a scenario of how it looks like. The third, in the sign example, is where I have everything packaged locally. I do not depend on any external system. I define my role responsibility mappings and user role mappings locally in my database, and I use my application logic. In addition, I connect to LDAP and Active Directory. Once again, another example to show you how this could be very bespoke. Last, but the final example or scenario that I want to share is in orange is I once again define everything locally, my role responsibility mappings and my user role mappings. I have application logic. I get some user information using a said user service, which we did not mention what it was, but it is a user service of some sort. But in addition to all this, I have some semblance of policies or logic that I use rules to evaluate. So I have a rules engine sitting either within my application scope or outside of it, and it has some rules that I'm evaluating by passing it some data. This is another example. This looks great. This looks like a typical application scenario that you would find in a normal workplace environment. Any of these could be possible. I don't see why they're wrong. Let's take a look at what. The first problem you face is that these are decentralized policies everywhere. Everything is decentralized, everything is bespoke, and every application does what it needs to do. Auditing nightmares. Every single application has their own bespoke styles of managing information. Audit becomes a nightmare. In the first two scenarios, I have roles and responsibilities or users defined in a local database. In the third and fourth, I have everything defined locally, and I have policies externally on the fourth scenario. Last but not the least, there is a lot of bespoke user management, especially in probably the blue one, the cyan one, and the orange one, where I have user role mappings defined locally. What is the problem with that? What if this user left? What if this user moved on to another part of the organization, another organization, or some new user joined the organization or company? How do I handle that? I am now responsible as an application to make sure that my database is updated. And this leads to a nightmare and a challenge. So let's take a quick look at what RMS can solve, or what we thought RMS should solve for us. Great. Post RMS, what happens? You first get rid of everything from your local database. No more user role mappings or role responsibility mappings in your local database. Application logic simply holds business logic for the application. All applications simply connect using an RMS client to a centralized RMS, or a responsibility management service. The responsibility management service, in turn, has role responsibility mappings and user role mappings as a part of its own offerings. Also, this responsibility management service makes direct connections to integrated services such as LDAP, Active Directory, user service, or any other bespoke integrated services that you in your organization provide. In addition to all this, the responsibility management service allows you to author policies that are specific to you. Hopefully, the colors indicate that each of these are specific to the applications that are listed to your left. The policies in pink refer to the application in pink, and so on and so forth. So you can create policies that are very specific to your application, which use a set of reference data or static data that is made available to you, use some amount of, role responsibility or responsibility management data that is made available to you and centralized. And in addition, you have access to logic that is built out and shared among these policies. So the policies themselves access the remaining systems that can make deterministic evaluations for dynamic data. So you have static data, you have input data, you have role responsibility data, and you have policies that actually talk to logic, which can derive dynamic responses for you. So Comparing this, let us take a quick look at the benefits of doing this. One, you get centralized policies. All your policies are located centrally. So if someone wanted to know what you do when you made a change to any policy, it's all central. Everything can be governed from a single system and can provide administrative and audit access for your policies. Auditing is centralized. We just talked about that. And user management is centralized. Now, if a user were to leave, move, or join the organization, there is exactly one place where I handle it. All applications will immediately be able to fetch that change and act upon it because it is centralized. So there is no more need for me to go to individual applications to determine what changed, when it changed, or how individual databases should be updated whenever a user moves, leaves, or joins the organization or company. So here's where I'm going to break once again for questions. If there are any questions, I'll take them now. Any questions about the slides that we've talked about thus far?
That's a no.
Great, thank you. Okay, great. So let's take a look at some of the technology choices that we made in order to create the responsibility management service. Once again, let's quickly go back to the picture because it's important. We want to create a standalone responsibility management system that individually maps to the role responsibility managements and user role mappings, provides you a portal to connect to your integrated services, which are required across multiple applications, provides you a central portal to author policies, and provides you a layer to connect to external systems that can drive logic that is required by your policies. So this is our wish list of items. How do we solve this? We solve this by using a few technologies. And let's take a look at, we had to go through a process of evaluating the technologies we used, and that's what I'm here to share with you. The first thing I wanted to talk about was HOCON. I don't know how many of you know HOCON. HOCON stands for Human Optimized Config Object Notation or Configuration Object Notation. It is something that was built by a company called TypeSafe, which is now called Lightbend. I have a link down below here, which tells you how you can read more about this. But before we get into that, why did we choose this? What did we want to do? Our intent was to use get and post operations. Obviously, we don't want to change data. We want to query data. And the best way to query data in the HTTP and RESTful formats is to use a get operation. Now, a get operation does not support a request body. So what is the next best option we could use? We would then prefer using a post operation because it supports a request body, but a post operation does not perform any kind of meaningful caching, whereas a put does. So a post operation was something that we were forced to use instead of a get. Now, HTTP does, the HTTP operations do support other operations that you could use, such as a search and a report, but those were not friendly to the rest of the organization, so we decided to stick with the get and a post. However, if your organization is more amenable to using other non-common HTTP operations such as search and report, you should avail of them because they have a request body and do functions similar to a get. So that is something I leave to you as a choice for you to evaluate and determine if that works for you. It did not work in our case. So we were forced to stick with get and post operations. Policy decisions should be queried. They should be non-mutating. So logically, it should be a get operation. But since we required a request body, which contained the inputs that the service consumer would provide, we were forced to use a post operation instead. Now, when we did a post operation, we noticed that there were two problems that we noticed. For some queries, we could get away using a get operation. It was simple. You just pass some query parameters and you're good to go. You can get a response. Get operations are exposed to character limits by certain technologies. So many technologies do not have this, but some technologies actually cause you to limit your get operation parameters. You cannot put a large parameter content in it. When you use JSON or other payloads such as XML or plain text, you notice that they get quite verbose. Now, when we started looking at how we could trim this verbosity, the first thing we found was there are two products, TOML, T-O-M-L, and HOCON, that provided us some betterment over what JSON, XML, or text could. We opted to use HOCON, and I will show you why in a little bit. HOCON trims the parameter verbosity by a significant amount, which led us to actually use that as our choice of payload formats. Great. What is HOCON? HOCON is a very simple syntax, low ambiguity, text format that you can use. It is a superset of JSON. So if you pass some JSON to a HOCON parser, it completely understands that. HOCON parsers understand JSON because JSON is a subset of HOCON in that it has more verbosity compared to what HOCON provides. HOCON, in addition, allows you to use comments. So when you pass in a payload, let us say in a post operation, you have some content, you definitely want to include some comments, especially if you have something that you want audited for a later purpose. JSON does not allow you comments, HOCON does. In addition, HOCON allows you to use multi-line strings, and I'll show you some examples later. HOCON allows you to use what is called includes and substitutions. We'll look at a slide in a little bit where you see what includes and substitutions look like. But one of the best benefits I found with using HOCON is it has built-in durations. There is no more ambiguity. There is no more long attribute names where I have to specify time in milliseconds. When I say time, I can actually pass it data that tells you whether it is seconds or milliseconds. And I'll show you that in a slide following. Once again, there is a link to what HOCON is, and it is listed below at the bottom of the slide deck. I don't know if there are questions on the YouTube channel, but this slide deck will be made available to you. It's on speaker deck. The Denver and Boulder JUG organizers will be sharing the slide deck with you later on.
Actually, there is a question from Deshaun Carter. He says, my app is using Drools. How do we transition the app Drools integration to app RMS Drools?
Great. So we will cover that in a little bit. That's an excellent question. Let's park it for 2 minutes. And I will get back to that real quick. So there is a little bit of work when you do Drools, and I will have to talk about that when we get towards it. Great. But thank you for the question. Great. So here is an example of where I'm using includes and substitutions. The first one I would like to talk to you about is substitutions. In substitutions, in a conf file, which is what a generic HOCON file looks like. A conf is an extension that I provided. It's a text extension. You can give it any name you want. We call it conf because HOCON stands for Human Optimized Config Object Notation. So we just called it .conf files. And that's what Lightbend also does. So it was a format that we decided to stick with. Now, if you notice, my first parameter attribute here says x equal to 10. This is a syntax that most of you are familiar with in JSON. HOCON looks similar. There are no double quotes. That is the first thing you notice, and we'll talk about that later. So I provided a value of x equal to 10. And later on, I am able to substitute x with a dollar variable. So if x changes, I don't have to go replacing everywhere x is used. I can simply just use substitutions in my logic, and I have successfully replaced x everywhere. And the last one I wanted to show you is durations. If you notice here, my duration is 5 seconds. I never specified z in seconds, z in milliseconds. I just specified s. I could have said 5D. It would have translated into 5 days. There is a whole syntax. Obviously, the entire syntax is made available at HOCON README files. You can definitely take a look at it.
So we have a question from Jim Moore. He says, those benefits from HOCON sound pretty much identical to YAML. Why not use that since it's more standard?
Yes, YAML has the same problem that you encounter with JSON, plus one additional problem in that there is a white space, requirement with YAML. That leads to more verbosity and a longer file size as well. Now with HOCON, we will package the file, and the next slide will actually show you how this trims it down further. So bear with me while I get to that in a minute. The second example I wanted to show you was inclusions. Inclusions are where I can create configurations that can be shared. And this is quite useful, and we will see the power when we actually go through how responsibility management systems work. So you create something that is shareable, and then you can actually include that within your own localized configuration with an include statement. The path is absolute path, so you basically a relative path, so you can provide it the path of where the other file is located, and it gets included. So if I were to do something like a include generic.conf, where generic.conf declares an x, a y, and a z, then I could very well do something like a.x and assure you that the value will be 10, a.y and the value will be 10, and a.z the value will be 5. So it allows you to create structures that include inclusion aspects where you can generalize some content and make it available for the rest of the files that use them. So it helps you build up your configurations. Now, here is an example of a small difference between how a HOCON payload and a JSON payload look like. And this should also solve the YAML question in that here is your JSON payload of a foo bar bars, where bars is a my value. You have a foo that declares a bars, that declares a bar, that declares a bars that has a my value. Its equivalent in HOCON is foo.bar.bars colon my value. As simple as that. You've reduced the verbosity. You could also do foo bar bars my value without any colons. So you could either get rid of the colons and keep the curly braces, or you could simply do a dot convention and get to the point where you are declaring the value. So if I were to also declare foo.bar colon and give it a value, that would very much do exactly what I was doing, where it would create a structure where bar would have a value and would have a sub value of bars, and that would be defined as my value. So you can do that, and let's take a look at that. Under employee, you notice that I created an employee structure on my JSON, and I gave it a colon to begin the declaration of an employee. The same in case of a HOCON, I could actually get rid of semicolons. They're optional, so I could include or choose not to include. Of course, this leads to some amount of confusion. In most of our code, we've actually removed semicolons. We mostly stick with the dot convention, but I will get to that in a minute. Now, another example, there you have first name and last name, Jane Doe listed here. And in a nested, I have login timeout in milliseconds. Obviously, we already talked about durations. So in here, I define a login timeout as 5 seconds instead of specifying a longer attribute name. My attribute name is now not a meaningful indicator of my duration. My duration is in the value. And that is something of a big change because it allows me to control how I pass data. I'm not forced to reconcile with what the end system is looking for. Now, if I were to create a full name attribute in my JSON, I am forcibly padding the first name and last name and creating a value. This is non-synthetic. I'm actually deliberately creating this. In case of HOCON, here I am using substitutions, doing $employee.first name, $employee.last name from within this employee, and I am able to create a full name right from there. Once again, I can change this logic down the line, but I have reduced how to create more content in my own source in order to generate and populate something for my payload. So that was another benefit we found. So you can create multiple HOCON structures, multiple JSON structures. You'll notice that you could create something where you don't have semicolons. You may actually optionally include semicolons, etc. So I don't know if this answers the question that Tim asked about YAML. The same rules apply with YAML. I'm going to pause for a minute to see if Matt, I get a response to that.
Well, so I was going to ask, everyone hates YAML, right? Like because of the white space and stuff, but does this require like YAML does, where it's 2 white spaces, or it's more like JSON where it really doesn't care?
It doesn't care at all. In fact, if you notice, it doesn't even look for white spaces or parentheses. It actually does dot convention under the hood. So whatever you specify here is actually converted into a dot convention by the time you receive it.
Nice.
So HOCON does simplify, and it is human optimized because it's only for your readability that you create structures with, I guess, indentations or curly braces. HOCON does not care. So you can actually create a properties file with dot separated values, and it will be converted into a HOCON format for you. You don't have to actually worry about it. So we've increased the scope of who can pass us what kind of data by switching to HOCON. And that is an immediate value add benefit that we got from using HOCON instead of JSON, YAML, or XML, or plain text for that matter. Does that answer your question, Matt?
Yep.
Great. So another technology feature that we chose to use, and this is a shameless plug, so I'm going to let you know before I tell you this, is we decided to use Eclipse Collections. And we want the system to be highly scalable, highly responsive, and be available at high demand volumes. Using Java collections frameworks did slow us down. And what we did find out was us using immutable structure hierarchies that Eclipse Collections offers out of the box helped us. You're free to choose other collections frameworks, but try to make immutable collections your objective when you want just queryable operations. If your operations don't require any mutations, why even bother with mutable collections? Make sure you use memory efficient collections and containers, and make sure you use immutable hierarchies in whatever collection framework that you use. My recommendation selfishly would be to use Eclipse Collections. You're free to use some other framework, but make sure you have immutability as a thought process when you're doing this. You also want to have some amount of increased code readability. Your code should Eclipse Collections does provide you a benefit of being able to directly act on collections instead of, let us say, a Java framework, a collections framework, where you have to step out of the collection and write a for loop, which has nothing to do with the collection itself. Or you create a lazy API and have to depend upon lazy evaluation of your collection in order to perform actions. Eclipse Collections gives you an eager API instead. So there are many benefits to using a robust collections framework, especially if you're doing a lot of this evaluation, because there is a lot of compute going into place. There's a lot of collections that you have to sort through. You get a lot of data. So think about and use something that provides you the benefits that you need. Once again, as with other slides, you have a link to where you can find details about Eclipse Collections at the bottom of the slide. Last and the most important decision we made was to get a policy engine. And I did chuckle a bit when I said decision, because policy engine is a decision-making tool. So we made a decision about the decision-making tool. And what we decided to, once we evaluated our choices, was to go with what is called an open policy agent. An open policy agent is an open source framework, as the name suggests. It is a general purpose policy engine. It does not have a lot of syntax, so there is no for loops, there is no if conditions. So watch out. You're not writing programming languages here. You're writing simple logic to evaluate content, right? It uses a format called Rego. Rego is a format that has been inspired by Datalog. It is a declarative native query language. So in a sense, it's a query language. It does not have a lot of conditional operators, iterative operators, etc. But it has certain amount of features that you program with. Policies are written as rule sets. They are very similar to rules. So here's where Dashan's question comes in. Your rules can be converted into policies. Now, there is some amount of manual intervention required when you do this. But the benefit you get is that your rules are localized to your system. Whereas if you were to create these as policy agents and ensure that they are being operated by an independent service, audit becomes extremely simple and easy. So that is the added value benefit of taking the effort to manually convert your rules into open policy. That said, if you decide to continue with writing your rules or decide to stick with your existing rules, your policy engine can actually reach out to the rules and make the evaluations, as long as there is a RESTful API exposed for those rules. The benefit is that you can cache some amount of rule logic within the policy engine. Other benefit, every system does not have to know the rules engine location, simply goes to the policy agent, gets the evaluation done. The policy agent in turn calls the rules engine for you. So it's shielded. Also reduces back pressure due to caching. So those are some of the things that you will find useful should you want to either convert from the rules to a policy engine, or should you want to back your rules engine with a fronting of a policy engine. Now, policies are typically queried as RESTful post operations. So Open Policy Agent reads your policies and immediately converts them into RESTful API for you. You don't have to do anything. You write your policy. I'm going to show you a simple policy later on as an example, but you write a simple policy that says, allow for this constraint based upon these conditions, and it will actually create a post operation for you that you can invoke. And this post operation will take the parameters as a request body, load them into that particular policy, evaluate it for you, and return an HTTP response back. Now, data and policy publishing is through RESTful put operations. We do not use put operations. I'm just sharing this as information. Ours is only read-only. Policy changes are something I'm going to talk about towards the end of our session. But for now, just know that it is possible to change policies using put operations. We did not choose to use this. So I'm just reiterating that. Now, one of the best benefits we found of using Open Policy Agent is you could launch this as a library for a service. So if you're running it locally, you launch it as a library, lo and behold, you have a policy agent running within your own application on your local desktop. You could also run it as an independent daemon. So you could allow it to sit outside as an independent service. It exposes a port that you can actually connect to and make post calls and get some information back. But one of the best benefits we found was that you could use it as a sidecar. So a sidecar is typically, if you use a container-based approach, you have your service sitting on a container and your sidecar attaches to it, very similar to how you have sidecars on motorbikes or motorcycles, where it just attaches itself to the main vehicle and allows you to drive, but you can seat other passengers in there. A similar concept for, I guess, containers is where you have your service running in a container, and you have a sidecar that attaches itself to it. Therefore, you make local host calls to the sidecar, get your information back, and lo and behold, you're in operation. The benefit of localhost, obviously, you have lesser network hops. You are directly accessing the information you look for, and there is very minimal latency, and there is immediate responses that you can use. Additionally, caching is shared between the application and the sidecar object, which can lead to even more performance improvements. We decided to use RMS as an OPA, we decided to use OPA in RMS as a sidecar. And that was one of the things that we very quickly found benefit to. And we'll take a look at that in the next slide. Here is a simple example of how Open Policy Agent is set up. Assume that this is one box, one host, one container, whatever you want to call it. If it's VM, it is on one single VM. If it's a container, this is on one single container. You have a service, we call it service one. You have an Open Policy Agent that is set up as a sidecar that runs alongside service one. So they go hand in hand. Whenever you deploy service one, auto-magically an instance of Open Policy Agent is deployed alongside it. That's what I want you to understand. When you set up your Docker Compose or whatever your organization provides, you provide it not one but two services. One of the services is your service one, and the other is the Open Policy Agent. So they go hand in hand. Now, here is an input payload that a service consumer can provide to you. An example, I've just provided a sample case where I have an input where I provide, let us say, a bucket, a client, and an access operation. Now, obviously, from the word bucket, you can assume that this is for some storage. It's for some sort of an OBS elastic storage. If you did not, that's okay. What we're doing is we are evaluating that a set client, client one, is allowed to read from bucket 2 in OBS. OBS stands for object-based storage, which is used as a mechanism for storing blobs, similar to S3 in AWS, etc. So you're providing it an input of, hey, I have a client one. Does client one have access to read from bucket 2? And this is how you provide the actual query structure. You have a local host, which is what your service exposes, 8181 is the port. You provided the domain, the policy, and your request. Is it an allow or a deny request? And I'll get to that in a minute. You're basically providing an allow deny as your endpoint on the context path and providing the full path to the service. I called it localhost because I was running it on my local laptop. When you go put in production, this portion will be replaced with whatever your production URL is. We use versions, so obviously you have versions, and the data being supplied is through a payload. So you have a query payload, you have a post operation, invoking service one. Service one, in return, calls a local host sidecar of the Open Policy Agent, and the Open Policy Agent does whatever it does and returns a decision back to service one, which can then go back and feed the response back to the invoker of the service. Now, what does Open Policy Agent have? It has two things. We talked about there being an input from the service consumer. We talked about reference data, and we talked about policies. So the same here. You have input from the service consumer, you have reference data or static data, and you have policies. So let's take a look at the reference data or static data. I define data.json that is pertinent to my service. Here is the data. It says for a bucket one, I allow client one to read and write. I allow client two to just write, not read. For bucket two, I allow client one to read. And that is what my request also asks for. Bucket two, client one, read. Is this an allow or a deny operation? And here my data says, hey, for bucket two, client one is allowed to read. So the straightforward answer should be yes. And how is this done? I have a Rego file that says allow. It says default allow equals false. So anyone making a request and none of these match, it'll return a false. And then allow, when the bucket name matches the input name, the client name matches the client, and the access matches what the access should be, then say allow. And that's what we do, and we return a true or something similar for a response from this service. That is the generic walkthrough of how you set up your code. You have an incoming payload that provides you inputs from the service consumer. You have some reference data. Now here the reference data is only data.json that is specific to this particular service. You could also depend upon integrated services such as LDAP or Active Directory or user service agents or whatever else. but a combination of data, both from bespoke data that is specific to the service and reference data that is generally available for the organization or company, is married together as data. And then you have policies that use such information in order to evaluate and provide you an allow or a deny request. Now, here I use the endpoint of allow because I have allow as my operation in my Rego file. If I were to change this allow to, let us say, Chandra, then my endpoint would actually read Chandra here. I hope that makes it clear in that everything I specify in my policy Rego file is actually being converted into an HTTP RESTful endpoint that my open policy agent exposes, and therefore my service can consume it. My service can choose to call it something else. Instead of allow, I could just say permit and deny, where open policy agent calls it allow and exposes allow, as long as my service makes a call to an endpoint of allow, right? Hopefully that is clear. And if it's not, I'm going to take a few questions if there are any right now.
So there's no questions in particular, but we did have some more comments from Jim Moore. So I just wanted to say that it was going back to the YAML versus HOCON. So he's saying YAML is a superset of JSON, which I didn't realize, but you can mix and match. So white space is only an issue if you choose for it to be. But let's admit, like, YAML's a pain in the ass. It bit me so many times. So, and then he says that the HOCON syntax is nicer in some ways. It's always this, suspicious of changing away from one well-established and understood standard without a strongly differentiating reason.
Absolutely. And that is a very fair point. So I'll take a minute there. Definitely, whatever you said may hold correct for you. But what we did find out was when you're passing payloads across the wire, you want to trim them down. You don't want them exposed to more white spaces. With YAML, you definitely, if you indent, if you want readability, you will have to indent. And HOCON, as the name suggests, is human optimized. Therefore, what it does is allows you to format when you read it, but when you pass it on the wire, you can trim it down. So there is a much more value add that you get in terms of readability that YAML generally provides, but is extensive on a verbosity scale. When you pass it on the wire, HOCON can do both. That is the benefit we found. Now, obviously, I'm not saying this is the way everybody should do it, but maybe you use TOML, maybe you use XML. You have to find what is right for you. And the intent and purpose of what I'm sharing with you today is not to impose technologies on you, but show you how we evaluated what we needed, right? So make your choices. And if your choice is to go with YAML, all power to you. Just be assured that it is the right format for what you're trying to do. That is my request. So as long as you meet that criteria, we are golden. I don't know if that answers your question, Jim.
I think that's fair. There's another question that just came in from Chris Allman. He says, "Hi, Chandra."
Hey, Chris.
I'll put this on the screen here so everyone sees it. Within this design, do policies support waiting in case of conflicting decisions? Or if any one policy affirmatively denies, does that denial overrule any other allows?
Yeah, so that's a very great question. And the answer is, it depends. That is the right answer. But let's go through this. So let's assume you have a nested policy structure and you have several policies that are being invoked by your main policy and they are being parallelly processed. Any one of them that returns a denial will immediately cause denial of the policy response. So that is as simple as that. But in different situations, maybe it is not just an allow or deny. You could also have a maybe, right? These are names that I made up. So what if you had a maybe and you wanted to operate something else with a maybe? And your service interpretation is going to determine what you choose to do with this value. Now, in my case, with this example, I am returning a simple Boolean object. You could choose to return something that is something more complex. It returns 10 policy evaluations, and 5 of them say yes, and 5 of them say no. Your service should be able to make a determination on what to do with it, right? So the it depends aspect comes in from how your service enforces and understands what open policy agent is sending to it, right? The decision is not an access control, but it is more like an evaluation result that the service chooses to interpret. I don't know if that answers your question, but you could actually respond back with a complex object that is not just a yay or a nay. You could actually return back saying, I evaluated 10, 5 said yes, 5 said no. Here you go. Do whatever you want to with this information. And that's what my open policy agent would return to the service. Now it is up to the service to interpret, prioritize, and determine what to do with this data. Is that a fair statement? Does that make it clearer?
Works for me.
Okay, great. Now, that leads to another interesting question. How do you manage audit in that case? So, one of the things that we've been very keen on is to make sure that there is thorough amount of testing of your open policy agent and policies before you put them into production. You don't want to put some random code into production that may return you ambiguous result, right? And we will take a look at that when we go through the architecture. I don't know how we're doing on time, but I want to move on and show you the architecture. Unfortunately, I can't see time on my screen, so.
You're at 1:10, so 20 more minutes.
20 minutes, so I better rush before I lose track. Great. So let's go look at the architecture patterns, and this will probably explain a little bit of what Chris was asking earlier. So there were two kinds of architectures that we went through. We first created what is called a federated responsibility management service. A federated system is where there is a unified responsibility management service that sits outside of your application or service. You invoke it, you get it to do some actions for you, everything is happy, and you're on a happy path. So that is federated responsibility management service. So let's take a quick look. You have a policy setup process. We talked about it when we talked about the policy lifecycle. You have different domains. There are developers on the domains who, using source control management and build servers, create policies. So they create policies, store them, commit them into their source control system. The build server picks them up and creates zip files or tarballs of those policies. All these policies go into a rule repository, very similar to a Maven repository. There is a rule repository. In fact, there could be one and the same. So you have a different group ID, artifact ID, and version, and lo and behold, you can dump your policies out there. So it's a simple mechanism to store policies somewhere. Then you create what is called an RMS service, and we talked about this multiple times. You have reference data and static data, and you create what is called a policy information point, a PIP. A PIP is basically something that connects to informational data, reference data, static data. It's called a PIP. And then you layer that with a responsibility management as a service. So you create a more generic service that can invoke the PIP, which is probably an underlying microservice of some sort. We'll not go into details of that. It is just that there exists a PIP service or microservice that connects to various systems that provide you information for the user. And then there is a responsibility management service that can call the PIP. No one else can call the PIP. And then you have Open Policy Agent as a sidecar, and the responsibility management system pulls in policies from the rule repository, loads them on a periodic basis using some sort of a release train model. So there's a release train saying, hey, every week or every day, pull the policies from the rule repository, make sure that they are up to date, and then push them to the Open Policy Agent for it to evaluate. That is the job of the responsibility management service. And then you have actual services, the end services, which provide inputs, use the static and reference data and the policies that were created in order to get their conditions evaluated from the responsibility management service. So it's a simple architecture where I have RMS as a service, exposes some amount of, RESTful APIs, post APIs, that the services can talk to using post operations. They provide you some amount of payload. Your responsibility management system uses that payload, uses the policies from the rule repository, and uses reference data and evaluates the policy and returns a response. This sounds great. This was a very simple solution to a major problem that we were having. So why am I still talking about it? There are a few problems with this approach. One, you have zero segregation and information barriers. So especially if you work in a financial institution or a very large company, you will notice that you will have requirements to segregate and information barrier your content. Team X cannot look at team-wise code, or team X cannot know team-wise data, etc. Any rogue policy script could actually lead to a loss of service across every domain. So you can create one policy that goes into an infinite loop of some sort. I'm not going to tell you how. And we talked about there being very less control statements in Rego files. But there is a potential for you to create rogue scripts. And creating a rogue script would bring down the responsibility management as a service itself. So you are effectively not available, and therefore defying one of our initial requirements. Thus, the responsibility management service has to become a gatekeeper for testing and coverage. You want your responsibility policies to be heavily tested, fully tested, and the coverage metrics had to be monitored. And that's when you would allow them. So you became a gatekeeper of sorts. In addition, we had a release train model where you would pick up policies exactly on a set interval. So what if someone wanted an immediate policy change? There was no way to do it unless you restarted the system and loaded all the policies again. It was a nightmare. Any out-of-band policy changes led to intermittent service unavailability for everybody. That's a problem. I mean, if service X is doing a policy change, why do I care as service Y? That became a problem. And we noticed as a side effect, right? And this is not like people are randomly making changes. When they make when a new policy is created or a new domain onboards, policy changes were very frequent. And this is because the data varied between what they saw in their test environments versus what they were allowed to use in a production environment. And this is very frequent and common a problem in the financial domain. Other domains may not have similar problems, but in the financial sector, there is a lot of separation of production data compared to what is available on a lower environment, right? And for very obvious reasons. So that is where policy changes were frequent, and it caused frequent outages. So beginning of the month was when policy agent was most required, was the time when it was mostly down. And that was a huge problem for us. So how did we solve this problem? Enter the dragon. We created what is called a distributed instead of a federated responsibility management service. Slight changes, but we'll take a look at that. Most of the content that you saw before looks similar. You still have developers creating your policies. You still have rule repository. You still have services. You still have PIPs. Nothing changed here. The only thing that you may have noticed is that the role service moved down. Instead of being up top, it moved down. It's a very aesthetic change, so I'm not going to worry about that yet, but we'll get to it. So now you have what is called the policy administrative service. If you remember the cycle we talked about, you have administrative services where you author policies, store them, and then you have a dissemination service which allows you to distribute them, and an evaluation service followed by a enforcement service and a reconciliation service. So here is your administration service, and this is where things start changing. So now, rather than depend on just static data, we now allow for more dynamism. So a domain can actually alter roles and responsibilities and user roles using the policy administration service. So we are now providing for a mechanism to update, not just query, but update data using for that specific domain, right? And this domain basically transfers all such role responsibilities and user role mappings to a role service, which also exposed APIs to alter data, which was very helpful for us. And any information that it stored was frequently being queried by the policy administration service. So there was a hydration mechanism to keep the policy administration service up to date with the data in the role service. There were systems external to this that could also change role services. So I'm not covering that, but we were hydrating the policy administration service irrespective from the role service on a frequent basis, which is important, and we'll talk about that. Also, instead of there being a release train process, the domain developers now, after they author the policies and store them, would actually make a RESTful call to publish a policy. So no more release train based approaches. You're not actually tied down to a end of the week or mid of the week to pull the policy. You can on demand issue a RESTful call to the policy administration service, which would then go back to the rule repository, pick up your rule, and let me show you. It would create what is called a policy bundle. A policy bundle is nothing but the policy along with the data for the role and service that was at the time it was created, right? So any change in this would require a republish of the policy. And I'll explain why this is important too. You have audit purposes for that. Great. So I first get my role responsibility data. I get my policy whenever it is pushed in, and I create what is called a policy bundle. Once I have a policy bundle, I have what is called a policy distribution service, a new service, which can read from the policy bundles repository and make it available to individual services which run their own sidecars. So rather than me as RMS running a sidecar for open policy, I have now deferred the open policy to exist on individual services. What is the benefit? Each open policy agent on the service can now individually pull the policies that it needs. So only the policies it needs and nothing more and nothing less. So if domain 2 creates a rogue policy, it does get published, but I am not picking it up. Therefore, my service is no longer impacted. I am only picking up service X policies. I don't care about domain 2 policies at all. In addition, all these services go through a centralized PIP location to get policy data, and therefore are fed the same way every time they make a request. So this is also centralized and cached. You still carry on the benefits of having a federated service here, but distributing and administration became separate, and creating policy bundles made things easier because now they were on-demand policy changes. And a change in a policy or a rogue policy only impacted the service that was consuming it and no one else. The benefits. There is now segregation and information barriers. You basically have to specify what policies you want. And there is, once again, RRM is like eating its own dog food, because it actually runs a role responsibility management on itself, saying, you are service X. Why do you need service 1's domain policies? You're not allowed, and therefore denies that request. So you cannot even request that. So RR, responsibility management service, uses responsibility management service. So it is implicit and no additional work is required. Rogue policy scripts cause only the outage for the domain that created the rogue policy script. No more gatekeeping requirements. So RMS does not have to gatekeep and ensure coverage. Now the domain has to do that. And if they fail in testing and fail in their code coverage, they get a slap on their wrist. It's not RMS that has to suffer the impact of such a negative situation. Any updated policies don't need a release train model. Domains can push policies on demand, makes it simple. You have ad hoc policy change availability. There is no downtime because each domain can simply publish a policy on demand. It is audited, and therefore there is no need for other systems or domains to suffer from that. One additional benefit we got was an implicit RBAC support model that came with this approach, because we now allow for not just a query, but also an update of data. And we'll talk about that in a bit. Quick time check. Am I left with at least 10 minutes, Matt?
You've got 8 minutes left.
Okay. So very quickly. We talked about policy bundles. It has policy files. It has policy static data specific to that domain, and you have standard, policy files that are commonly shared across multiple. So we provide for some common files, and let's take a look at it in a picture. It's very similar to a Maven structure. You have a domain, you have a policy, you have a version under which you have policy bundles, one or more policy bundles. A domain is like a Maven group ID. A policy is like an artifact ID, and a version is like a version in Maven. And you have individual artifacts under that. As an example, for domain 1, we saw in the pictures earlier, you created policy 1. You could also have policy 2. You have version 1.0.0. You could also have version 1.1.0 or 2.0.0. And it can have one or more policy bundles under it. A policy bundle, when exploded, enriched OPA bundle, has the domain policy, domain data, and also data that is common across every possible domain. So when you invoke policy 1, it could actually use anything that was declared in RBAC API, RBAC, orgs API, LDAP, config, Active Directory API, etc. So all these other Rego files serve as dependencies that are potentially used by the policy1.rego. So I'm providing for additional support metrics of generally commonly used policies that you can avail within your particular policy. So rather than everybody talk about, hey, I need to create an LDAP connection, let me just go write that in my policy Rego. I provide you an LDAP API and LDAP implementation for that, right? So it makes things easier, and testing becomes easier because we also expose an API here. Now here is, once again, just a reiteration. This is how it looks like. You have services. The services basically have individual sidecars. RMS no longer has open policy agent. So the sidecars are actually distributed by us and deployed alongside the services. Rules are created as policies into a rule repository, pushed on demand into an administrative service, which creates a policy bundle, which can be distributed by a distribution service. And then your policy information points remain the same. Policy agent setup, I'm going to quickly run through this because basically you can create OPA policy configurations. You can find this information online at openpolicyagent.org. We basically provide where to get the policy from, who's allowed to access the policy, how often you can poll. Here is the command that you use in your Docker file. It's an exec command which runs OPA which is installed as a part of your base image on your Docker or whatever similar container that you use. And we provide the config path, which is what we defined as the content here. So we provide a configuration. Here's an example of how it looks like. We created a library that is shareable. We talked about this earlier. We created some common libraries. We created an RBAC policy library where user has responsibilities given a user ID, action, and resource, and it does some kind of logic with it. My application policy basically can invoke this RBAC policy library and therefore directly access the functions that were declared in the RBAC policy library. Here's some data example that I used. For an application user, I have certain amount of policies. For an admin, I have different policies. And these are two data files I can supply alongside these Rego files. And based upon the user's, the service consumer's request, they're either passing me an app user or an app admin, and I know the responsibilities that they can access. I also specify who the membership should be limited to, and these are constraints that can be evaluated in some other libraries such as LDAP or Active Directory. Last but not the least, I want to spend 2 minutes on this. This was an amazing productivity tool that we built. We are looking to open source this, but this is something that helped a lot. So very quickly, it is a functional work-in-place policy editor. It parses and validates OPA policy. IntelliJ did not have anything to do that. And we use the language reference from OPA. The link is below, so please feel free to refer to that. Prior to us having any kind of a plugin, this is how it looked like. You created a Rego file. You had some issue on line 12. There was a missing double quote at the end of the line. Nothing else shows you that there is an error, and this would fail miserably. Once we created our plugin, first you notice a cool logo. This is what is the most important thing according to me. There's a cool logo for the file. You see error marks. You see where your error is in the gutter icons. And you start noticing that there are syntax highlighting. So package, import, equal to, etc. show in different colors. Comments show in different colors. And notice line number 12 actually shows you that there is an error. And that translates into line number 15 saying, hey, you're missing a double quote somewhere here. And I'll show you in the next slide that this is indicative of where the error is. Also, inline comments show up in gray. When you hover over that, you notice that it actually tells you that you have some problem where you got a double quote where it was not expected at input.user. So somewhere there was a double quote missing. You notice that there is an error in the gutter icon. So it takes care of what IntelliJ normally does for Java files or similar, right? And this was something we built. So I'm very proud to say that this was something that worked out for us. Once you fix your errors, you obviously get the green tick and everything looks hunky-dory and colorful. And of course, the most important thing, you have a very cool looking icon. We also created a settings for our IntelliJ where you could color theme. I was very much responsible for this. Most people prefer light screens. I prefer dark screens. So I wanted a color theming. So I made sure that Darkula was covered and we have a color theme that we specified. So we are actually looking forward to open sourcing this tool, making it available as an IntelliJ plugin. So that's what I wanted to cover today. But in summary, I just wanted to share that responsibility management as a service can resolve a lot of issues. Your choice of payload is important, right? I'm not saying use HOCON. We use HOCON. You may choose JSON, XML, YAML, whatever text. Choose what you need because the choice of a payload format is important. Your choice of architecture is important. In our case, we found that a distributed model worked better for us. Maybe for you, a federated works better. So make sure you make that evaluation. We made mistakes, learn from that, right? So choose whatever is right and evaluate it. Measure, execute, repeat, right? Distributed policy engines can actually alleviate some amount of back pressure. They can reduce outages and maintenance downtimes. And last but most importantly, creating something for a developer to increase their productivity enhances the usage and the productivity of the entire service. And with that, I'm going to share some links. These are available for you when you actually check out the slides. Questions?
So I'm going to add myself back in. Now, one of the problems is we do have a delay, right, with YouTube. So it's possible that, questions will take a little while to roll in.
Understood.
So, it's been great. Good talk. I liked it. There is a countdown thing. You ready? It's right here. we'll see. I don't think we get any questions. So.
Great. Great. Thank you so much for this. I noticed that there was a question from Greg. If you could just share the YouTube link for this particular presentation, that would be great.
So do you have a PDF link?
Yeah. So I believe I actually have a speaker deck link that I shared in an email with the JUG leaders.
Yep. Let me look for that here.
So if you could just put that in the YouTube, that'd be great. Thank you so much.
Mm-hmm. So we got a number of kudos, some thanks, some Matt Henry loves the plugin, John loved the talk. Awesome.
Thank
talk.
you. Thank you.
We'll let you go and have your evening back. I'm proud to hear that you survived. What was it, a 5-day outage at your house?
Yes, we had a power and internet outage for 5 days. Yes, it was an ordeal.
And how did the internet? You didn't have internet? You just used
No. I tethered and provided a talk at GIDS.
In India, and it worked. Like there was Nice. Who's your provider?
T-Mobile.
T-Mobile. I got T-Mobile too, so nice to hear. All right. Well, enjoy your evening. Thanks everyone for coming, and we'll see you next month.
Thank you, attendees. Thank you, JUG leaders, and I appreciate you joining this call. Thank you so much for giving me the opportunity.
You're welcome. Bye.
Thank you.